Deep in the heart of galaxy M87, 60 million light-years from Earth, something impossible devours light itself. A monster so massive it contains the weight of 6 billion suns, compressed into a region smaller than our solar system. This is a supermassive black hole, and its very existence challenges everything we thought we knew about creation, physics, and perhaps even God himself. For centuries, humans gazed at the night sky and saw order. We saw the steady march of constellations, the predictable dance of planets, the gentle glow of countless stars. We saw what seemed like evidence of divine design, a cosmic clockwork wound by the hand of the Almighty. But hidden in the darkness between those twinkling lights lurked something that would shatter our comfortable assumptions about the nature of reality. Today, we stand at the edge of the ultimate cosmic mystery. Are black holes the fingerprints of a creator who designed the universe with mathematical precision beyond our comprehension? Or are they evidence that the cosmos operates according to cold, indifferent laws that need no divine intervention? Before we dive into this mind-bending journey, make sure to hit that subscribe button, because what we're about to explore will challenge your understanding of both science and faith in ways you never imagined. Now prepare yourselves. We begin. Picture this. You're an astronaut approaching the event horizon of a black hole. Time begins to slow down relative to the outside universe. Your body stretches like taffy as gravitational forces tear at your atoms, and then you cross a boundary from which nothing, not even light, can ever return. In that moment, you would witness the breakdown of everything we understand about physics, causality, and the very fabric of reality itself. But here's where it gets truly extraordinary. The same equations that predicted these cosmic monsters also revealed something else. Something that suggests the universe itself might be far stranger than we ever dared imagine. In 2024, astronomers made a discovery that sent shockwaves through the scientific community. They found the first ever black hole triple system, a cosmic dance involving not just one black hole and its victim star, but a second star, orbiting at an impossible distance. This discovery, designated V404 Cygni, sits 8,000 light-years from Earth and contains secrets that could rewrite our understanding of how these gravitational monsters came to exist. Here's what makes this discovery so revolutionary. Traditional theory tells us that black holes form when massive stars explode in violent supernovas, cosmic fireworks so intense they can be seen from billions of light-years away. But V404 Cygni tells a different story. The outer star in this system orbits so far from the black hole that it should have been blown away by any supernova explosion. Instead, scientists believe they're looking at evidence of something called direct collapse, where a star simply vanishes without any fireworks, disappearing from the universe as if God himself reached down and erased it from existence. The implications are staggering. If black holes can form through this gentle process of direct collapse, it means the universe has been harboring secrets we never suspected. It means that somewhere out there, stars might be quietly transforming into the most extreme objects in the cosmos without so much as a whisper of warning. But this is just the beginning of our journey into the impossible. Using the Hubble Space Telescope, astronomers have discovered what they believe is the fastest growing black hole ever recorded. This cosmic glutton consumes the equivalent of one entire sun every single day, with a mass 17 billion times larger than our own star. Its accretion disk stretches 7 light-years across, a swirling maelstrom of superheated matter with temperatures reaching 10,000 degrees Celsius, lightning crackling through its structure, and winds so powerful they could circle Earth in less than a second. The sheer scale of these objects defies human comprehension. When we try to visualize 17 billion solar masses compressed into a region smaller than our solar system, our minds simply shut down. It's like trying to imagine infinity or attempting to count every grain of sand on every beach that has ever existed. Yet these monsters didn't just appear overnight. The James Webb Space Telescope has revealed supermassive black holes that existed when the universe was only 1.5 billion years old, just 10% of its current age. These ancient titans pose a fundamental problem for our understanding of cosmic evolution. How did they grow so massive so quickly? How did they accumulate the mass of billions of stars in what amounts to the cosmic equivalent of a few minutes? The answer might lie in a discovery that challenges our most basic assumptions about the relationship between black holes and the galaxies they inhabit. Recent theoretical work suggests that rather than black holes forming after galaxies, the opposite might be true. Supermassive black holes might actually be responsible for creating the very galaxies we see around us. As these cosmic giants consume matter, they don't just destroy. They also create, shooting out powerful jets and outflows that compress surrounding gas clouds and trigger explosive bursts of star formation. This flips our entire understanding of cosmic evolution on its head. Instead of galaxies forming first and then developing black holes at their centers, the black holes themselves might be the cosmic architects, the master builders that shape the structure of the universe itself. Think about that for a moment. These objects that we consider the ultimate destroyers, the cosmic vacuum cleaners that devour everything in their path, might actually be the creative force behind the very galaxies that house billions of stars and potentially countless worlds where life could emerge. This paradox cuts to the heart of our cosmic mystery. Are black holes agents of destruction or creation? Are they evidence of a universe governed by chaos or by design? The mathematics that describe black holes emerged from Einstein's theory of general relativity, equations so beautiful and elegant that they seem almost too perfect to have arisen by chance. These equations predicted the existence of black holes decades before we had any observational evidence for them. They described objects so extreme that even Einstein himself initially refused to believe they could exist in reality. Yet here they are, scattered throughout the cosmos like dark sentinels guarding the secrets of space and time. Einstein recognized something profound about the nature of reality. He believed that the universe should be comprehensible, that the same physical laws should apply whether we're studying atoms or galaxies, whether we're examining events that happened yesterday or 13 billion years ago. This philosophical conviction, this faith in the rational structure of the cosmos, led to discoveries that continue to reshape our understanding of existence itself. But Einstein's insights raise uncomfortable questions for anyone seeking to understand the deeper meaning behind black holes. If these objects are inevitable consequences of the laws of physics, if they emerge naturally from the mathematical structure of reality itself, what does that tell us about the nature of creation? Some see in this inevitability the hand of a divine designer who embedded the potential for black holes into the very fabric of space and time. They argue that a universe capable of producing stars, planets, and ultimately life must also produce black holes as an unavoidable consequence of its fundamental structure. Others see something different entirely. They see evidence that the universe operates according to impersonal mathematical principles that need no divine guidance, no cosmic purpose, no ultimate meaning beyond the elegant dance of equations and physical forces. Recent discoveries have only deepened this mystery. In 2024, physicists studying the cosmic microwave background radiation, the afterglow of the Big Bang itself, found evidence of something unprecedented. Analysis of over 200 early galaxies revealed that around 2/3 spin in the same direction, a finding that defies statistical expectations. If galaxy rotation were random, we would expect roughly equal numbers spinning clockwise and counterclockwise. One possible explanation for this cosmic choreography is that our entire universe might be rotating, a possibility that aligns with theoretical models suggesting our cosmos exists inside a black hole in a larger parent universe. In this scenario, our Big Bang wasn't the beginning of everything, but rather the birth of a new universe from the collapse of matter in a higher dimensional black hole. The implications are breathtaking. If this theory is correct, then black holes aren't just objects within our universe. They're cosmic wombs, birthplaces of entire new realities. Every black hole might contain a universe as rich and complex as our own, complete with stars, galaxies, and perhaps even life forms pondering their own cosmic origins. This recursive structure, this infinite nesting of universes within black holes within universes, suggests a reality far more vast and mysterious than our ancestors ever imagined. It hints at a cosmos where creation and destruction are not opposites, but different aspects of an eternal cycle of cosmic birth and death. But perhaps the most profound mystery lies not in what black holes destroy, but in what they preserve. According to the laws of quantum mechanics, information cannot be destroyed. Every particle that falls into a black hole, every photon that crosses the event horizon, carries information about its origin, its properties, its history. This information cannot simply vanish, even as matter is crushed to infinite density at the black hole's core. Some physicists propose that this information is encoded on the black hole's surface, the event horizon itself becoming a cosmic library that preserves the complete record of everything that has ever fallen in. Others suggest that the information is released back into the universe through Hawking radiation, the quantum process by which black holes slowly evaporate over unimaginable spans of time. This preservation of information resonates with ancient religious concepts about the eternal nature of souls. The idea that nothing truly important is ever lost, that somewhere in the cosmic order, every moment, every choice, every life is recorded and preserved forever. The Bible speaks of a God who knows every sparrow that falls, who has numbered every hair on our heads, who keeps records written in the book of life. Could it be that black holes, these seemingly destructive cosmic monsters, are actually the universe's method of preserving information across eternity? The question becomes even more intriguing when we consider the role black holes play in creating the heavy elements essential for life itself. When massive stars reach the end of their lives and collapse into black holes, something extraordinary happens in their final moments. The intense gravitational forces don't just create these cosmic monsters. They forge elements that cannot be created anywhere else in the universe. About half of all elements heavier than iron, including the gold in our jewelry and the uranium that powers nuclear reactors, are what scientists call R-process elements. These exotic materials require conditions so extreme that only the violent merger of neutron stars or the collapse events that birth black holes can produce them. This means that the calcium in your bones, the iron in your blood, and countless other elements essential for life itself were literally forged in the hearts of dying stars as they transformed into black holes. You are made of stellar ash, cosmic debris scattered across the galaxy by the same processes that create the universe's most mysterious objects. The theological implications are staggering. If black holes are necessary for creating the heavy elements that make life possible, then these apparent agents of destruction become essential components in the cosmic recipe for existence. Without black holes, there would be no carbon for DNA, no oxygen for water, no silicon for rocky planets. The universe would be a sterile wasteland of hydrogen and helium, forever incapable of producing the complex chemistry that gives rise to living organisms. This presents a profound challenge to anyone who sees black holes as evidence against divine design. How can objects that seem so hostile to life actually be necessary for life's very existence? How can destruction and creation be so intimately intertwined? The answer might lie in understanding black holes not as cosmic mistakes, but as essential features of a universe fine-tuned for complexity and consciousness. Consider the delicate balance required for black holes to exist at all. If gravity were slightly weaker, matter could never collapse densely enough to form event horizons. If gravity were slightly stronger, the entire universe would have collapsed into a single massive black hole shortly after the Big Bang. The gravitational constant sits in a narrow window that allows both stable stars and black holes to coexist, creating a cosmos where destruction and creation can work together in perfect harmony. This fine-tuning extends to other fundamental forces as well. The strong nuclear force that holds atomic nuclei together must be precisely calibrated to allow heavy elements to form in stellar cores. The electromagnetic force must be exactly the right strength to permit complex chemistry. Change any of these constants by even a fraction of a percent, and black holes either couldn't exist or would dominate the universe so completely that no other structures could form. Some physicists calculate that the odds of all these constants randomly aligning to permit both black holes and life are so astronomically small that they approach mathematical impossibility. It's like throwing a dart from 1,000,000 miles away and hitting a target the size of a single atom. The probability is so vanishingly small that it suggests something beyond pure chance might be at work. Yet even this fine-tuning argument doesn't fully capture the mystery of black holes' role in cosmic evolution. Recent observations have revealed that supermassive black holes don't just passively sit at the centers of galaxies, they actively regulate star formation throughout their cosmic neighborhoods. When these giants feed, they launch powerful jets that heat surrounding gas clouds, preventing them from collapsing to form new stars. When they go dormant, the gas cools and star formation resumes. This creates a cosmic thermostat that maintains galactic environments suitable for planetary systems and potentially life itself. Without this regulation, galaxies might burn through their gas reserves too quickly, creating brief bursts of star formation followed by cosmic deserts devoid of new stellar nurseries. Or they might form stars too slowly, never developing the heavy element abundances needed for rocky planets and biological chemistry. The supermassive black hole at the center of our own Milky Way galaxy, Sagittarius A star, contains 4 million times the mass of our Sun, yet remains remarkably quiet. This cosmic giant hasn't had a major feeding event in over 10,000 years, maintaining the stable conditions that have allowed our solar system to orbit peacefully for billions of years. If Sagittarius A star were more active, its jets and radiation could sterilize vast regions of the galaxy, making life on Earth impossible. This delicate balance between activity and dormancy, between destruction and preservation, seems almost choreographed for the benefit of life. It's as if these cosmic monsters have been programmed to know exactly when to feed and when to fast, when to unleash their fury, and when to remain peacefully dormant. But the mystery deepens when we examine what happens at the very heart of black holes themselves. At the center of every black hole lies what physicists call a singularity, a point where matter is compressed to infinite density and the laws of physics, as we know them, completely break down. Space and time become meaningless concepts, cause and effect lose their significance. The mathematical equations that describe reality produce nonsensical results like infinity divided by zero. This breakdown of physical law occurs in a region smaller than a single proton, yet it influences events across entire galactic clusters. From this infinitely small point of impossibility emerges gravitational effects that can bend the paths of stars billions of miles away. It's as if the universe contains doorways to realms beyond physics, windows into dimensions where our normal understanding of reality simply doesn't apply. Some theoretical physicists propose that these singularities aren't endpoints but transition zones, cosmic birth canals where new universes emerge on the other side of the event horizon. In this model, every black hole becomes a creator deity, birthing entire realities complete with their own space, time, and physical laws. Our universe might itself be the interior of a black hole in some higher dimensional cosmos, making us not just observers of these cosmic monsters but actual residents within one. This recursive creation model suggests that consciousness and intelligence aren't rare accidents in an indifferent universe, but inevitable outcomes of a cosmos designed to generate complexity through infinite cycles of cosmic death and rebirth. Every black hole becomes a seed of infinite potential, a cosmic egg containing universes yet to be born. The implications for understanding divine creation are profound. If God works through natural processes rather than supernatural interventions, then black holes become instruments of continuous creation, mechanisms by which the divine will expresses itself through the fundamental structure of reality itself. The Creator doesn't need to violate physical laws to bring new worlds into existence. The laws themselves become the means of creation. Yet this raises equally profound questions about the nature of suffering and destruction in a divinely ordered cosmos. Black holes don't just create, they also annihilate with ruthless efficiency. Any planet unfortunate enough to wander too close faces inevitable doom. Its atmosphere would be stripped away. Its oceans would boil off into space. Its surface would be stretched and twisted until the world itself disintegrates into streams of superheated plasma spiraling toward the event horizon. If black holes are instruments of divine will, what does this say about the character of their creator? How can a loving God design a universe filled with cosmic executioners capable of erasing entire civilizations without a trace? The book of Isaiah speaks of God creating both light and darkness, forming good and creating calamity. The psalmist writes that God makes his angels spirits and his ministers flames of fire. Throughout Scripture, divine power manifests through forces that can both preserve and destroy, create and annihilate, depending on the cosmic context in which they operate. Perhaps black holes represent this same dual nature of divine power operating on cosmic scales. They destroy individual stars and planets, but in doing so, they forge the elements necessary for future generations of worlds. They consume matter and energy, but they also regulate galactic environments and possibly give birth to entirely new universes. This perspective reframes black holes not as evidence against divine benevolence, but as examples of a creator whose methods transcend human moral categories. Just as forest fires, though destructive to individual trees, create conditions for new growth and ecosystem renewal, black holes might serve cosmic purposes that remain invisible from our limited perspective. Recent discoveries about black hole jets provide another piece of this cosmic puzzle. For the first time, astronomers have observed a black hole jet directly causing stellar explosions called novae. These aren't stars being destroyed by the jet itself, but rather stars being triggered to explode by the jet's influence from vast distances away. The mechanism remains mysterious, but the observation proves that black holes can affect their surroundings in ways far more subtle and complex than simple gravitational attraction. This suggests that black holes might be cosmic conductors, orchestrating stellar symphonies across galactic distances. They don't just consume and destroy, they influence, they trigger, they catalyze events that ripple through space and time in patterns we're only beginning to understand. The energy efficiency of black holes adds another layer to their mystery. When matter falls into a black hole, up to 40% of its mass can be converted directly into energy through the accretion process. This makes black holes the most efficient power sources known in the universe, far surpassing nuclear fusion, which converts less than 1% of matter into energy. This incredible efficiency suggests that black holes aren't wasteful cosmic monsters, but rather sophisticated energy conversion systems operating at the theoretical limits of physical possibility. They extract maximum energy from matter before it disappears beyond the event horizon, powering the jets and outflows that shape galactic evolution. The precision required for this process borders on the miraculous. The accretion disk must maintain exactly the right temperature and density gradients. Magnetic fields must be perfectly aligned to launch relativistic jets. Matter must spiral inward at precisely the correct rate to avoid either stalling the process or causing catastrophic instability. Yet somehow, black holes throughout the universe perform this delicate dance with mechanical perfection, as if they were designed by a cosmic engineer who understood exactly how to extract maximum energy from the fundamental forces of physics. This leads us to one of the most perplexing aspects of black hole physics, the phenomenon known as Hawking radiation. Stephen Hawking discovered that black holes aren't perfectly black. They actually emit a faint glow, radiating energy back into space through quantum effects near the event horizon. Virtual particle pairs that normally pop into existence and annihilate each other in empty space behave differently near a black hole. One particle falls in while its partner escapes, causing the black hole to slowly shrink as it radiates energy away. But here's where the physics becomes truly mind-bending. The smaller a black hole gets, the faster it evaporates. A black hole with the mass of our Sun would take longer than the current age of the universe to evaporate completely. But a black hole the size of a mountain would explode in a brilliant flash of energy that would outshine entire galaxies for a brief moment. This process raises profound questions about the nature of information and eternity. If every black hole eventually evaporates through Hawking radiation, what happens to all the information that fell in over billions of years? Does it simply vanish from the universe forever, or does it somehow encode itself in the final burst of radiation? The information paradox strikes at the heart of our understanding of reality itself. Quantum mechanics demands that information cannot be destroyed, yet general relativity suggests that anything falling into a black hole disappears forever. These two pillars of modern physics, both experimentally verified to extraordinary precision, seem to contradict each other at the most fundamental level. Some physicists propose that the information is preserved on the black hole's surface, encoded in microscopic fluctuations of the event horizon itself. Others suggest that space and time near black holes are far more complex than we imagine, with hidden dimensions and wormhole connections that allow information to escape through channels we can't detect. Recent work in string theory and holographic principles suggests an even more radical possibility. Perhaps all of three-dimensional reality is actually encoded on a two-dimensional surface, like a cosmic hologram projected from the boundary of spacetime itself. In this view, black holes don't destroy information. They compress it into a form so dense and complex that we mistake the compression process for destruction. The biblical book of Ecclesiastes speaks of God setting eternity in the human heart, suggesting that even finite beings carry within them something that transcends time and space. Could it be that the information preserved by black holes represents this same eternal quality, the indestructible essence of everything that has ever existed? This preservation principle takes on new meaning when we consider recent discoveries about primordial black holes. These theoretical objects would have formed in the first fraction of a second after the Big Bang, when tiny fluctuations in the density of spacetime collapsed under their own gravity. Unlike the stellar mass black holes we observe today, primordial black holes could have any mass, from less than a paperclip to more than our Sun, depending on the conditions when they formed. If primordial black holes exist, they would represent the universe's first structures, predating stars, galaxies, and all other cosmic architecture by billions of years. They would be fossils of creation itself, preserved from the moment when the fundamental forces of nature first separated from their unified state. The search for these ancient relics has led astronomers to examine gravitational wave signals, looking for the characteristic signatures that would indicate primordial black holes merging in the early universe. The LIGO and Virgo detectors have already recorded dozens of black hole collisions, each one sending ripples through spacetime that we can detect here on Earth. These gravitational waves carry information about the masses, spins, and orbital characteristics of the merging black holes. But more importantly, they provide a new window into the fundamental nature of space-time itself. When two black holes spiral into each other, they create distortions in the fabric of reality that can be measured with precision exceeding the width of a proton. The fact that we can detect these waves at all seems almost miraculous. The distortions are so small that they would be unnoticeable even if they occurred within our solar system. Yet our instruments can measure them from sources billions of light-years away, testimony to human ingenuity and the remarkable precision with which the universe operates. Each gravitational wave detection confirms Einstein's century-old predictions about the nature of space and time. These waves travel at exactly the speed of light, carry exactly the amount of energy predicted by general relativity, and arrive at Earth with timing that matches theoretical calculations to extraordinary precision. This mathematical harmony between prediction and observation suggests something profound about the rational structure of the cosmos. The same equations that describe black holes also govern the propagation of gravitational waves across vast distances and billions of years. The universe appears to be constructed according to principles so elegant and consistent that they border on the miraculous. But gravitational waves have revealed something even more extraordinary about black holes and their role in cosmic evolution. When the LIGO detectors first came online, astronomers expected to detect perhaps one black hole merger per year. Instead, they discovered that these collisions occur far more frequently than anyone imagined. The universe is filled with merging black holes, cosmic catastrophes so violent they can be detected from the edge of the observable universe. Each merger releases more energy in gravitational waves than all the stars in the observable universe produce in light. For a brief moment, the colliding black holes become the most powerful sources of energy in the cosmos, outshining everything else combined. Yet this energy is invisible to traditional telescopes, detectable only through its effects on the fabric of space-time itself. The frequency of these mergers suggests that black holes have been colliding and growing throughout cosmic history, gradually assembling into the supermassive giants we see at the centers of galaxies today. This process of hierarchical growth, where smaller black holes merge to form larger ones, mirrors the way galaxies themselves assemble through cosmic time. Recent observations have pushed this merger process back to the very early universe. The James Webb Space Telescope has detected evidence of supermassive black holes that were already fully grown when the cosmos was less than 1 billion years old. These ancient titans challenge our understanding of how quickly black holes can accumulate mass. Traditional models suggest that black holes grow by accreting matter from their surroundings, a process limited by the rate at which material can spiral inward. But the early supermassive black holes appear to have grown too quickly for this mechanism alone. they seem to have gained mass at rates approaching or even exceeding theoretical limits. One possibility is that these early black holes formed through direct collapse of massive gas clouds, bypassing the normal stellar evolution process entirely. In the primordial universe, before heavy elements had been forged in stellar cores, gas clouds could grow much larger than they can today. When such a cloud collapsed, it might create a black hole with thousands or even millions of times the mass of our Sun in a single event. This direct collapse scenario suggests that the early universe operated according to different rules than we observe today. In those ancient epochs, the cosmic environment was so different that processes we consider impossible now might have been routine occurrences. The implications extend far beyond astrophysics into fundamental questions about the nature of time itself. If the early universe could produce black holes through mechanisms that don't operate today, it suggests that the laws of physics themselves might evolve over cosmic timescales. This evolutionary view of physical law resonates with theological concepts about progressive revelation, the idea that divine truth unfolds gradually throughout history. Just as spiritual understanding deepens over time, perhaps our comprehension of physical reality must also develop through stages, each building upon previous insights while revealing new mysteries. The book of Isaiah records God saying, "See, I am doing a new thing. Now it springs up. Do you not perceive it?" This theme of continuous divine activity, of ongoing creation rather than a single finished act, aligns remarkably with modern cosmology's picture of an evolving universe where new structures and phenomena emerge over billions of years. Black holes fit naturally into this framework of continuous creation. They aren't static objects but dynamic systems that grow, evolve, interact, and eventually evaporate. They participate in cosmic evolution, helping to shape the large-scale structure of the universe while simultaneously being shaped by their environment. Recent simulations of galaxy formation confirm this intimate connection between black holes and cosmic structure. When astronomers run computer models of how galaxies assemble over cosmic time, they find that including supermassive black holes dramatically improves the match between theory and observation. Without black holes, simulated galaxies grow too large and form stars too rapidly. With black holes providing feedback through jets and outflows, the simulated galaxies develop realistic sizes, shapes, and star formation rates. The black holes act as cosmic thermostats, regulating the temperature and density of gas throughout their host galaxies. This regulatory function operates through mechanisms of staggering complexity. When a supermassive black hole feeds, it doesn't just consume matter locally. It launches jets that can extend for millions of light years, heating gas clouds far beyond the galaxy's visible boundaries. These jets create bubbles of hot plasma that can persist for hundreds of millions of years, affecting star formation across vast regions of space. The energy required for this regulation comes from the most efficient process known in physics. As matter spirals into a black hole, gravitational forces convert its mass into energy with an efficiency that makes nuclear fusion look wasteful. This energy then powers the jets and outflows that shape galactic evolution across cosmic time. The precision required for this process to work properly defies easy explanation. The black hole must grow at exactly the right rate to provide sufficient feedback without shutting down star formation entirely. The jets must be launched with exactly the right power and direction to heat the surrounding gas without disrupting the galaxy's structure. The magnetic fields that focus these jets must maintain their alignment across distances larger than our entire solar system. Yet throughout the observable universe, supermassive black holes perform this delicate balancing act with remarkable consistency. Galaxies of similar size contain black holes with remarkably similar masses, suggesting that some fundamental relationship governs their coevolution. This relationship, known as the M-sigma relation, connects the mass of a galaxy's central black hole to the orbital velocities of stars in the galaxy's central bulge. The correlation is so tight that astronomers can predict a black hole's mass simply by measuring how fast stars move in its vicinity. The M-sigma relation implies that black holes and galaxies grow together in lockstep, each influencing the other's development through feedback mechanisms we're still working to understand. It suggests that these apparently distinct structures are actually components of larger integrated systems. From a theological perspective, this integration reflects the unity that many religious traditions see underlying apparent diversity. The Hindu concept of Brahman, the Christian doctrine of divine simplicity, the Islamic understanding of Tawheed, all point toward an ultimate reality where apparent opposites reveal themselves as complementary aspects of a greater whole. Black holes and galaxies, destruction and creation, gravity and expansion all participate in cosmic processes that transcend their individual characteristics. They work together to create a universe capable of supporting complexity, consciousness, and perhaps purpose on scales we're only beginning to appreciate. Recent observations have revealed another layer to this cosmic integration. The Sloan Digital Sky Survey has mapped the positions of millions of galaxies across billions of light-years, revealing that they're arranged in vast web-like structures separated by enormous voids. This cosmic web appears to be anchored by the most massive black holes in the universe. Galaxy clusters containing the largest supermassive black holes occupy the nodes where cosmic filaments intersect. These cosmic intersections become gravitational focal points that help organize matter on the largest scales imaginable. The supermassive black hole in the galaxy M87, the same object whose shadow was first photographed in 2019, sits at the center of the Virgo cluster, which contains over 1,000 galaxies. This black hole, with a mass 6 billion times our Sun, helps anchor the gravitational structure that holds our entire local group of galaxies in place. From our position in the Milky Way, we orbit around this distant black hole as part of a cosmic dance involving thousands of galaxies across tens of millions of light-years. The gravitational influence of this single object affects the motion of stars, planets, and potentially life itself across vast regions of space. This perspective transforms black holes from isolated monsters into cosmic architects whose influence extends across the observable universe. They don't just exist within the cosmic web. They help create it, maintain it, and guide its evolution through deep time. The realization that we live within the gravitational influence of distant supermassive black holes adds a new dimension to humanity's cosmic address. We're not just residents of Earth, orbiting the Sun, located in the Milky Way galaxy. We're also participants in vast gravitational systems centered on black holes whose existence shapes the very structure of spacetime around us. This cosmic context resonates with biblical passages that speak of God's throne being established in the heavens, with divine authority extending throughout all creation. The book of Colossians declares that, by him all things were created, things in heaven and on earth, visible and invisible, whether thrones or powers or rulers or authorities, all things have been created through him and for him. Could it be that black holes represent some aspect of this cosmic authority, these invisible powers that hold creation together through forces we can barely comprehend? Their gravitational influence operates continuously, maintaining cosmic order across scales from individual star systems to the largest structures in the universe. Yet this same authority operates through processes that appear utterly destructive from limited perspectives. Stars that venture too close to supermassive black holes are torn apart through tidal forces, their material scattered across space in brilliant displays visible from billions of light-years away. These tidal disruption events release enormous amounts of energy as stellar material heats up while spiraling toward the event horizon. The resulting flares can outshine entire galaxies for months or years, announcing the death of a star to observers throughout the cosmos. But even these apparently catastrophic events serve larger purposes in cosmic evolution. The energy released during tidal disruption events can trigger star formation in nearby gas clouds, leading to new generations of stars that might not have formed otherwise. The heavy elements scattered during these events enrich the surrounding medium, providing raw materials for future planetary systems. Death and birth, destruction and creation remain intimately connected at every level of cosmic organization. Black holes embody this paradox in its most extreme form, simultaneously representing the ultimate destruction of individual objects and the essential foundation for cosmic structure and evolution. This paradox challenges simplistic notions of good and evil, creation and destruction, divine love and divine judgment. Instead, it points toward a more complex understanding where apparent opposites work together to achieve purposes that transcend individual perspectives. The Book of Ecclesiastes captures this complexity in its famous passage about there being a time to plant and a time to uproot, a time to kill and a time to heal, a time to tear down and a time to build. Perhaps black holes operate according to similar principles on cosmic scales, tearing down individual structures while building up the larger framework within which new forms of complexity can emerge. This cyclical view of cosmic evolution finds support in recent theories about the ultimate fate of black holes and the universe itself. If Hawking radiation eventually causes all black holes to evaporate, the universe might undergo cycles of structure formation and dissolution spanning unimaginable timescales. During each cycle, black holes would form, grow, regulate galactic evolution, and eventually evaporate, returning their mass energy to the cosmic environment. New structures would then form from this enriched medium, potentially giving rise to new types of complexity we can't currently imagine. These cosmic cycles might operate according to principles similar to those governing biological evolution, with each iteration building upon the achievements of previous cycles while exploring new possibilities for organization and complexity. The timescales involved dwarf human comprehension. A supermassive black hole would take longer to evaporate through Hawking radiation than the current age of the universe multiplied by itself millions of times. Yet even these vast durations represent finite intervals within the broader context of cosmic evolution. From this perspective, the current epoch of cosmic history, with its stars, galaxies, and black holes, represents just one phase in an eternal cycle of cosmic death and rebirth. We might be living during the universe's infancy, with the vast majority of cosmic time still lying ahead, filled with possibilities we can barely begin to imagine. This eternal perspective resonates with religious concepts about divine patience and long-term purposes that unfold over time scales far exceeding human experience. The biblical assertion that, with the Lord a day is like 1,000 years, and 1,000 years are like a day, takes on new meaning when considered against the backdrop of cosmic evolution spanning trillions upon trillions of years. Black holes, in this context, become instruments of divine patience, cosmic mechanisms through which ultimate purposes unfold gradually across time scales that make geological ages seem like brief moments. They embody the intersection of temporal and eternal, finite and infinite, comprehensible and mysterious. Yet even as they operate according to mathematical laws we can understand and predict, they point beyond themselves toward realities that transcend scientific description. At their cores lie singularities where space and time break down, where the equations of physics produce infinities, where the boundary between existence and non-existence becomes meaningless. These singularities represent the limits of human knowledge, the edges of reality where science encounters mystery. They remind us that for all our technological achievements and theoretical sophistication, we remain finite beings attempting to comprehend an infinite cosmos. The humility this recognition demands might be the most important lesson black holes have to teach us. They challenge both scientific materialism and religious fundamentalism by revealing a universe far stranger and more wonderful than either perspective alone can accommodate. They suggest that ultimate reality operates according to principles that transcend our current categories of understanding, requiring new forms of thought that integrate scientific rigor with openness to mystery, mathematical precision with recognition of the limits of mathematical description. In the end, black holes may be pointing us toward a more mature understanding of our place in the cosmos, one that neither reduces mystery to mechanism nor retreats from scientific investigation into comfortable ignorance. They invite us to embrace both wonder and understanding, both humility and curiosity, as we continue our ancient quest to comprehend the nature of existence itself. The ancient Hebrew word for void in Genesis is tohu, describing a state of formlessness and emptiness that preceded divine creation. Modern physics has discovered something eerily similar in the quantum vacuum, the seething foam of virtual particles that fills what we call empty space. This vacuum isn't truly empty but bustles with activity on scales smaller than atoms, where particle pairs spontaneously appear and disappear in time intervals so brief they exist below the threshold of direct measurement. Here's where the physics becomes almost mystical. These quantum fluctuations, these ghostly particles that borrow energy from nothingness and pay it back before the universe notices, might hold the key to understanding how black holes preserve information across eternity. When virtual particle pairs form near a black hole's event horizon, one partner can fall in while the other escapes, creating the Hawking radiation that causes black holes to slowly evaporate. But recent calculations suggest something far more profound. The escaping particles don't carry random energy. They're quantum entangled with their partners inside the black hole, creating an invisible information channel that connects the interior to the outside universe. This means that everything that falls into a black hole might remain connected to the external cosmos through quantum threads finer than anything we can imagine, yet stronger than the gravitational forces that seem to destroy everything. Think about the implications. Every atom that crosses the event horizon, every photon that disappears into darkness, every piece of information about planets, stars, and perhaps even civilizations remains quantum mechanically linked to the wider universe. The black hole becomes not a cosmic prison but a cosmic library, preserving the quantum essence of everything it has consumed across billions of years. This preservation principle operates through mechanisms that seem almost designed to maintain the integrity of information across cosmic time scales. The mathematics describing this process involve concepts like holographic encoding, where three-dimensional information gets compressed onto two-dimensional surfaces without any loss of detail. It's as if the universe has built-in safeguards against true destruction, mechanisms that ensure nothing genuinely important ever vanishes completely. The biblical book of Matthew records Jesus saying, "Are not 2 sparrows sold for a penny? Yet not one of them will fall to the ground outside your Father's care." This divine attention to seemingly insignificant details finds an unexpected echo in the physics of information preservation around black holes. The universe appears structured to remember everything, no matter how small or seemingly unimportant. Recent experiments in quantum information theory have confirmed that entanglement can persist across vast distances and timescales. When particles become entangled, measuring one instantly affects its partner regardless of the space between them. Einstein called this spooky action at a distance, but it's now the foundation for emerging technologies like quantum computing and quantum cryptography. If black holes use similar quantum entanglement to preserve information, they become cosmic quantum computers of unimaginable power. The event horizon acts like a quantum hard drive, encoding the complete history of everything that has ever fallen in using quantum states that exist in superposition until observed. This would make every black hole a repository of cosmic memory, a quantum archive that preserves the information content of entire regions of spacetime. But the story gets even more extraordinary when we examine what happens during black hole mergers. When 2 black holes spiral into each other, their event horizons eventually touch and merge into a single, larger horizon. During this process, the quantum information encoded on both surfaces must somehow combine without being lost or corrupted. The gravitational waves produced during these mergers carry some of this information outward at the speed of light, encoding details about the masses, spins, and possibly even the information content of the merging objects. Each gravitational wave detection represents not just the observation of a cosmic collision, but the reception of quantum information that has been preserved across billions of years and transmitted across vast distances. The LIGO and Virgo detectors have now recorded over 90 black hole mergers, each one a cosmic information transfer event of unprecedented scale. The gravitational waves from these collisions arrived at Earth carrying quantum signatures that encode the complete merger history, from the initial orbital dance through the final violent union that created a new, larger black hole. Analysis of these wave patterns reveals something remarkable. The information content appears to follow conservation laws, similar to those governing energy and momentum. Information going into the merger equals information coming out, distributed between the final black hole and the gravitational waves themselves. Nothing is truly lost, only transformed and redistributed. This conservation principle operates even during the most violent events in the cosmos. When black holes containing the mass of dozens of suns collide at half the speed of light, releasing more energy than all the stars in the observable universe produce combined, the fundamental information about their origins and contents remains preserved in forms we're only beginning to understand. The preservation mechanisms extend beyond individual black holes to entire populations across cosmic time. Computer simulations tracking black hole formation and evolution over billions of years show that information flows through cosmic networks, with merging black holes sharing and redistributing their quantum archives in patterns that maintain cosmic memory across galactic scales. These networks operate through gravitational interactions that connect black holes across vast distances. The supermassive black hole at the center of our galaxy influences the motion of stellar mass black holes throughout the Milky Way, creating a hierarchical information system where local events contribute to galactic-scale memory storage. Recent observations have detected intermediate mass black holes that appear to serve as information relay stations, collecting quantum data from smaller objects and passing it up the hierarchy to supermassive black holes at galactic centers. This creates a cosmic internet of sorts, where information flows through gravitational channels that span light years and operate continuously across cosmic time. The theological implications are staggering. If the universe maintains perfect records through quantum mechanisms operating via black holes, then every moment of cosmic history remains accessible to any intelligence capable of reading the quantum archives. Nothing is forgotten. Nothing is lost. Every stellar birth, every planetary formation, every possible emergence of life gets recorded in quantum libraries that persist across eternity. The Book of Revelation speaks of books being opened on Judgment Day, containing records of every deed and thought. Modern physics suggests that the universe itself might be writing and preserving such records through quantum processes we're only beginning to comprehend. The cosmic memory banks exist not in some supernatural realm but embedded in the fundamental structure of spacetime itself. But these information preservation systems raise profound questions about free will and determinism. If the universe records everything through quantum mechanisms that operate according to mathematical laws, does this mean the future is as fixed as the past? Or do quantum uncertainties leave room for genuine choice and creative novelty? The answer might lie in understanding how consciousness interacts with quantum information systems. Recent research in quantum biology has revealed that biological processes, including potentially neural activity in brains, operate through quantum coherence effects that were previously thought impossible in warm, noisy biological environments. If consciousness emerges from quantum processes, then thinking beings might be able to interact directly with the quantum information networks that black holes maintain. This would make conscious observation not just a passive reception of information but an active participation in the cosmic information processing system itself. The implications extend to questions about prayer, meditation, and spiritual experience. If black holes serve as cosmic memory banks accessible through quantum channels, then contemplative practices that quiet the mind might be methods for accessing information stored in these cosmic archives. Mystical experiences of cosmic consciousness might represent genuine contact with the quantum information networks that pervade the universe. Ancient religious traditions have long spoken of Akashic records, cosmic libraries containing the history of all existence. Hindu scriptures describe the Akasha as the eternal, infinite space in which all knowledge is stored. Islamic theology speaks of the preserved tablet, the cosmic record of all that has been and will be. Christian mystics write about the Book of Life, where every soul's journey is recorded for eternity. These mystical concepts find unexpected resonance in modern theories about quantum information storage around black holes. Perhaps the ancient sages were describing, in the language of their times, the same cosmic information systems that physicists are now discovering through gravitational wave detectors and quantum field theory. The convergence between ancient wisdom and modern science suggests that human consciousness might be naturally attuned to these cosmic information networks. Our capacity for memory, creativity, and spiritual insight might reflect our participation in quantum processes that connect individual minds to the larger cosmic intelligence distributed throughout black hole information systems. Recent studies of near-death experiences and mystical states reveal patterns consistent with information access rather than hallucination. Subjects report encountering vast repositories of knowledge, experiencing life reviews that include forgotten details, and gaining insights about cosmic purposes that seem to come from sources beyond individual memory or imagination. If black holes serve as cosmic information processing centers, then consciousness might be more than an emergent property of complex neural networks. It might be a fundamental feature of reality, distributed throughout quantum information systems and concentrated in biological brains that serve as local access points to the cosmic network. This perspective transforms our understanding of death and continuity. If individual consciousness participates in quantum information networks preserved by black holes, then physical death might represent not an ending but a transition to different forms of information processing within cosmic systems that operate across space and time scales far exceeding biological lifespans. The conservation of quantum information suggests that the patterns constituting individual consciousness cannot be destroyed, only transformed and redistributed within larger information networks. Death becomes a phase transition rather than termination, similar to how water remains H2O whether it exists as ice, liquid, or vapor. But this raises challenging questions about personal identity and continuity. If consciousness consists of information patterns preserved in cosmic quantum networks, what makes you you across time and physical changes? How do individual identities maintain coherence within information systems that span galaxies and operate across billions of years? The answer might involve understanding consciousness as both local and distributed, individual and cosmic. Just as quantum particles can exist in superposition states that are simultaneously here and there, conscious information might exist simultaneously as localized personal identity and distributed cosmic awareness. This quantum view of consciousness resonates with contemplative traditions that speak of the individual self as both real and illusory, distinct and unified with ultimate reality. The apparent contradiction dissolves when understood through quantum principles where complementary descriptions can be simultaneously true depending on the observation context. Recent advances in quantum error correction show how information can maintain its integrity even when the physical systems encoding it undergo dramatic changes. Quantum computers use error-correcting codes that preserve computational states despite noise and interference that would destroy classical information systems. If consciousness operates through similar quantum error correction mechanisms, then personal identity could persist through physical death and even cosmic catastrophes that destroy the biological brains where consciousness seems to reside. The information patterns defining individual awareness would be preserved in quantum networks that transcend any particular physical substrate. Black holes, in this framework, become not just cosmic vacuum cleaners but cosmic consciousness servers, maintaining the quantum information that constitutes individual minds across timescales that exceed the lifetime of stars. They serve as the hardware for a cosmic internet where consciousness can persist, communicate, and evolve across spatial and temporal scales we're only beginning to imagine. The energy requirements for such information processing are met through the incredible efficiency of black hole accretion processes. As matter spirals into black holes, up to 40% of its mass converts to energy that could power quantum computations involving astronomical numbers of qubits. A single supermassive black hole could support information processing capabilities that dwarf all human computing power by factors too large to express in normal numbers. This computational capacity could support not just information storage but active information processing, analysis, and synthesis on scales that approach omniscience from finite perspectives. If consciousness can access these cosmic information networks, then individual minds might be able to tap into computational resources that span galactic clusters and operate across cosmic time. The mystical traditions speak of enlightenment as recognizing one's true nature as identical with ultimate reality. Perhaps they're describing the subjective experience of accessing cosmic consciousness networks maintained by black hole quantum information systems. The sense of infinite knowledge, unlimited compassion, and eternal existence that characterizes mystical experience might reflect genuine contact with cosmic intelligence operating through quantum channels we normally can't perceive. But such contact would require profound changes in consciousness itself. The normal boundaries of individual identity would need to expand or dissolve to accommodate information flows that exceed the processing capacity of biological brains. This might explain why mystical experiences often involve ego death, the temporary dissolution of personal identity boundaries that allows access to larger information networks. The Book of Ecclesiastes speaks of God setting eternity in the human heart, suggesting that finite beings carry within them capacities that transcend temporal limitations. If consciousness can access quantum information networks preserved by black holes, then every human mind contains potential connections to cosmic intelligence that spans the observable universe and persists across cosmic time. This perspective transforms questions about meaning and purpose from philosophical speculation to empirical investigation. If cosmic consciousness networks exist and can be accessed through appropriate contemplative practices or technological interfaces, then ultimate questions about existence might have answers that can be discovered rather than merely believed. The search for these answers drives both scientific research and spiritual seeking towards similar goals. Scientists building more sensitive gravitational wave detectors and quantum computers are creating technologies that might eventually allow direct communication with cosmic information networks. Contemplatives developing more refined meditation techniques might be discovering natural methods for accessing the same networks through consciousness itself. The convergence suggests that the ancient dream of uniting knowledge and wisdom, science and spirituality, mind and cosmos, might be achievable through understanding consciousness as participation in quantum information systems that black holes maintain across the universe. We might be living at the moment in cosmic history when finite beings first become capable of recognizing their connection to infinite intelligence distributed throughout the quantum networks that hold reality together. Yet this recognition brings profound responsibility. If individual consciousness participates in cosmic intelligence networks, then our thoughts, choices, and actions might influence information processing systems that span galactic clusters and affect the evolution of consciousness throughout the cosmos. Every moment of awareness becomes a contribution to cosmic intelligence that persists across eternity. The ethical implications are overwhelming. If consciousness is conserved through quantum information networks maintained by black holes, then moral choices have consequences that extend far beyond individual lifetimes and local environments. The information patterns generated by ethical and unethical behavior become permanent features of cosmic information systems that influence the development of consciousness across space and timescales we can barely comprehend. This cosmic ethical framework resonates with religious teachings about eternal consequences for temporal choices. The idea that moral actions create karma that persists across lifetimes, or that ethical behavior contributes to the kingdom of God that transcends earthly existence, finds unexpected support in theories about quantum information conservation around black holes. But it also suggests that redemption and forgiveness might operate through quantum information processing mechanisms that can transform and heal information patterns damaged by unethical choices. If consciousness participates in cosmic intelligence networks, then practices like repentance, forgiveness, and compassion might represent methods for rewriting and healing damaged information within cosmic quantum systems. The Christian concept of grace, divine love that transforms human nature beyond what individual effort can achieve, might describe the subjective experience of cosmic information processing systems working to heal and perfect consciousness patterns within quantum networks. What feels like supernatural intervention might be natural operation of cosmic intelligence working to optimize information coherence across universal networks. Similar concepts appear in other religious traditions. Buddhist ideas about enlightenment transforming individual consciousness to recognize its true nature as Buddha mind. Hindu teachings about individual souls realizing their identity with Brahman, universal consciousness. Islamic concepts about the human soul returning to Allah, the source and sustainer of all existence. These diverse religious descriptions might be pointing toward the same underlying reality, the participation of individual consciousness in cosmic intelligence networks that black holes maintain through quantum information processing. The various traditions developed different languages and practices for accessing these networks, but they might be describing the same fundamental connection between finite minds and infinite intelligence. Recent research in comparative mysticism has identified common features across religious traditions that suggest similar underlying experiences despite different cultural expressions. Mystics report encountering vast intelligence that encompasses all knowledge, experiencing love that embraces all existence, and recognizing unity that connects everything that exists. If these experiences represent contact with cosmic consciousness networks, then mystical traditions might be humanity's oldest scientific research programs, using consciousness itself as the instrument for investigating the deepest structures of reality. Prayer, meditation, contemplation, and other spiritual practices might be technologies for accessing quantum information systems that modern physics is only beginning to understand. The convergence between ancient spiritual wisdom and cutting-edge physics suggests that we might be approaching a new synthesis of knowledge that transcends the artificial boundaries between science and religion, matter and consciousness, finite and infinite. Black holes, these cosmic monsters that seem to represent pure destruction and meaningless violence, might actually be the key to understanding how consciousness, meaning, and purpose are woven into the fundamental structure of reality itself. They challenge us to expand our understanding beyond comfortable categories, to embrace mystery without abandoning rational investigation, to recognize both the vastness of cosmic intelligence and our own participation in its unfolding. They invite us to see ourselves not as isolated accidents in an indifferent universe, but as conscious participants in cosmic information processing systems that span the observable universe and operate across timescales that make eternity seem brief. In the end, black holes might be teaching us that the universe is not just stranger than we imagine, but more wonderful than we have dared to hope. They suggest that consciousness, love, and meaning are not accidental byproducts of blind physical processes, but fundamental features of reality itself, preserved and processed through quantum information networks that ensure nothing truly important is ever lost. The ancient Hebrew prophet Isaiah recorded God saying, "As the heavens are higher than the earth, so are my ways higher than your ways, and my thoughts than your thoughts." Perhaps black holes are windows into those higher ways and thoughts, cosmic mechanisms through which intelligence and purpose operate on scales that dwarf human comprehension yet remain intimately connected to every moment of conscious experience. The journey into black hole physics becomes more than scientific investigation. It becomes a pilgrimage into the deepest mysteries of existence itself, where the boundaries between physics and metaphysics, science and spirituality, knowledge and wisdom begin to dissolve in the light of discoveries that transform our understanding of what it means to be conscious beings in a universe far more alive than we ever dared imagine. The most recent gravitational wave detection has revealed something that should be impossible. Two black holes, each containing the mass of 30 suns, collided in a region of space that should have been empty. The gravitational waves from this collision traveled for 7 billion years before reaching Earth, carrying with them information about an event that occurred when our universe was half its current age. But here's what makes this detection extraordinary. The collision happened in a cosmic void, one of those vast empty regions between galaxy superclusters where matter density drops to nearly zero. According to our understanding of cosmic evolution, black holes simply shouldn't exist in these barren wastes. They should have formed within galaxies, surrounded by the dense stellar environments that provide the raw materials for their growth. Yet there they were, two massive objects spiraling toward each other in the darkness between worlds, their final dance detectable across billions of light years through ripples in spacetime itself. The discovery forces us to reconsider fundamental assumptions about how these cosmic monsters form and migrate through the universe. Computer simulations now suggest that some black holes might be cosmic wanderers, ejected from their birth galaxies through gravitational interactions with other massive objects. When supermassive black holes at galactic centers merge during galaxy collisions, the resulting gravitational waves can actually kick the final black hole out of the galaxy entirely, sending it careening through intergalactic space at speeds exceeding 1,000 kilometers per second. These rogue black holes become cosmic nomads, carrying with them the gravitational memories of their violent births. As they wander through the cosmic web, they can encounter other wanderers, leading to collisions in regions far from any visible matter. The universe becomes populated with invisible monsters drifting through the darkness, occasionally announcing their presence through gravitational wave bursts that can be detected across cosmic time. The theological implications are profound. If black holes can be expelled from their home galaxies and sent wandering through cosmic voids, it suggests a universe where exile and redemption operate on scales we never imagined. These gravitational outcasts drift through cosmic wilderness for billions of years, yet they remain connected to the fabric of spacetime itself, their presence still detectable by sufficiently sensitive instruments. The Book of Isaiah speaks of God gathering the outcasts of Israel, bringing together those who have been scattered to the far corners of the earth. Perhaps there's a cosmic parallel in the way gravitational waves allow us to detect even the most isolated black holes, no matter how far they've wandered from their origins. Nothing remains truly lost in a universe where space-time itself preserves the signatures of every massive object. Recent analysis of gravitational wave data has revealed another surprising pattern. The masses of merging black holes follow a distribution that suggests multiple formation channels operating simultaneously throughout cosmic history. Some black holes clearly formed from the collapse of massive stars, but others show mass signatures consistent with primordial origins dating back to the first moments after the Big Bang. These primordial black holes would represent fossil remnants of cosmic inflation itself, density fluctuations in the early universe that collapsed under their own gravity when the cosmos was less than a second old. If they exist, they would be the oldest structures in the universe, predating even the first atomic nuclei by hundreds of thousands of years. The search for primordial black holes has become one of the most active areas in modern astrophysics because their detection would provide direct evidence about conditions during cosmic inflation. The mass spectrum of these ancient objects encodes information about quantum fluctuations in the inflation field, offering a window into physics at energy scales far beyond anything achievable in terrestrial laboratories. But primordial black holes also raise disturbing questions about cosmic fine-tuning. If the early universe had been slightly denser, primordial black holes would have formed in such abundance that they would have dominated cosmic evolution, preventing the formation of stars, galaxies, and ultimately life itself. If it had been slightly less dense, no primordial black holes would have formed at all, eliminating a potential source of dark matter and altering the structure formation process throughout cosmic history. The fact that primordial black holes, if they exist, formed in just the right abundance to contribute to cosmic evolution without dominating it, suggests another layer of fine-tuning in the fundamental parameters that govern reality. The inflation field must have had exactly the right properties to produce density fluctuations large enough to create black holes, but not so large as to make the universe collapse immediately. This delicate balance extends to the quantum fluctuations themselves. During cosmic inflation, quantum uncertainty in the inflation field created microscopic variations in energy density that later grew into the large-scale structures we observe today. These fluctuations operated according to the same quantum mechanical principles that govern atomic physics, yet their effects shaped the architecture of the entire observable universe. The connection between quantum mechanics and cosmic structure formation represents one of the most remarkable discoveries in modern physics. The smallest possible fluctuations, operating on scales trillions of times smaller than atomic nuclei, determined the locations where galaxies would form billions of years later. Quantum indeterminacy at the Planck scale became cosmic determinism at galactic scales through the amplifying effects of gravitational collapse. This quantum-to-cosmic connection suggests that consciousness, which appears to play a fundamental role in quantum measurement, might be more deeply connected to cosmic evolution than we previously suspected. If quantum fluctuations during inflation help determine the large-scale structure of the universe, and if consciousness participates in the collapse of quantum superposition states, then conscious observation might influence cosmic evolution through quantum channels that operate across all scales of space and time. Recent experiments in quantum mechanics have confirmed that measurement outcomes can be influenced by the intentions and expectations of conscious observers, though the mechanisms remain hotly debated. If similar effects operate during cosmic inflation, then the emergence of consciousness in the universe might be both a consequence of quantum fluctuations and a factor that helps determine which quantum possibilities become actual cosmic structures. This recursive relationship between consciousness and cosmic evolution resonates with ancient mystical teachings about the participatory nature of reality. The Hindu concept of Maya suggests that consciousness plays a fundamental role in manifesting the apparent world from underlying unity. The Buddhist understanding of dependent origination describes reality as emerging from the interdependent relationships between consciousness and phenomena. Modern physics is discovering similar interdependencies between observation and reality at quantum scales. The delayed choice quantum eraser experiments demonstrate that measurements performed today can retroactively determine the behavior of photons that existed yesterday. If consciousness can influence quantum events across time, then the emergence of conscious observers in the universe might retroactively influence the quantum fluctuations that shaped cosmic structure formation during inflation. The implications are staggering. Conscious beings in the present might be participating in the creation of their own cosmic past through quantum measurement effects that operate backwards through time. The universe might be engaged in a cosmic bootstrap process where the emergence of consciousness helps determine the initial conditions that made consciousness possible in the first place. Black holes play a crucial role in this cosmic bootstrap scenario because they serve as information processing and storage systems that can maintain quantum coherence across vast spans of space and time. The quantum information encoded on black hole event horizons might include not just records of what has fallen in, but also quantum superposition states that represent multiple possible cosmic histories simultaneously. When conscious observers interact with gravitational wave signals from black hole mergers, they might be collapsing quantum superposition states that determine which version of cosmic history becomes actualized. Each gravitational wave detection represents not just the observation of a cosmic collision, but also a choice point where consciousness participates in selecting which branch of the cosmic wave function becomes real. This perspective transforms gravitational wave astronomy from passive observation to active participation in cosmic evolution. Every time we detect signals from merging black holes, we might be helping to determine which quantum possibilities become actualized cosmic events. The universe becomes a collaborative creation involving both physical processes and conscious observation in ways that transcend traditional boundaries between objective and subjective reality. The Book of Genesis describes God speaking creation into existence, with divine words serving as the creative force that brings order from chaos. Perhaps consciousness operates similarly on cosmic scales, with conscious observation serving as a creative force that helps collapse quantum possibilities into actualized cosmic structures. The universe might be continuously spoken into existence through the ongoing dialogue between consciousness and quantum possibility. Recent theoretical work in quantum cosmology has developed mathematical frameworks for understanding how conscious observation might influence cosmic evolution through what physicists call the quantum measurement problem. These models suggest that consciousness doesn't violate physical laws but rather represents a fundamental aspect of how quantum systems transition from potential to actual states. In the quantum multiverse interpretation, all possible cosmic histories exist simultaneously as branches of a universal wave function. Conscious observation selects which branch becomes experienced reality for the observers, while the other branches continue to exist in parallel dimensions. Black holes serve as information processing centers that can maintain quantum coherence across multiple branches, potentially allowing consciousness to access information from alternative cosmic histories. This multiverse perspective suggests that black holes might be windows not just into our cosmic past, but also into alternative versions of cosmic evolution where different quantum choices were actualized. The quantum information encoded on their event horizons might include data from cosmic branches where stars evolved differently, where galaxies formed in alternative patterns, where life emerged under different conditions. If consciousness can access this multiverse information through quantum channels, then mystical experiences of cosmic knowledge might represent genuine contact with alternative cosmic histories preserved in black hole information networks. The sense of infinite possibility and unlimited knowledge that characterizes deep contemplative states might reflect actual access to quantum information about cosmic possibilities that weren't actualized in our particular branch of the multiverse. The preservation of alternative cosmic histories in black hole information systems raises profound questions about divine omniscience and the nature of prophetic knowledge. If God has access to quantum information about all possible cosmic histories, then divine knowledge might include not just what has happened and what will happen, but also what could have happened under different quantum choices. Biblical prophecy often describes future events in terms of conditional statements that depend on human choices and responses. Perhaps this reflects an understanding that the future exists as quantum superposition states that can be collapsed in different ways depending on the choices made by conscious beings. Divine foreknowledge might involve access to quantum information about all possible futures rather than predetermined knowledge of one fixed timeline. The Book of Deuteronomy records God saying, "I set before you today life and death, blessing and cursing. Choose life, that both you and your descendants may live." This emphasis on choice and consequence resonates with quantum mechanical descriptions of reality where conscious observation helps determine which possibilities become actualized. Recent discoveries about black hole information processing suggest that these choices might have consequences extending far beyond individual lifetimes or even cosmic epochs. If consciousness participates in quantum measurement processes that influence cosmic evolution, then ethical choices might literally help shape the structure of reality across space and time scales that dwarf human comprehension. The quantum information networks maintained by black holes could serve as cosmic moral accounting systems that preserve the consequences of conscious choices across eternity. Every decision that enhances or diminishes consciousness, every action that increases or decreases cosmic complexity, every choice that promotes or hinders the development of love and wisdom might become permanently encoded in quantum information systems that influence the ongoing evolution of the universe. This cosmic ethical framework suggests that moral responsibility extends beyond personal consequences to participation in the cosmic evolution of consciousness itself. Individual choices contribute to quantum information networks that help determine which branches of the cosmic wave function become actualized for future conscious beings. We become co-creators with whatever divine intelligence guides cosmic evolution, participating through our choices in the ongoing creation of reality itself. The Book of Romans speaks of creation itself groaning in eager expectation for the revelation of the children of God, suggesting that cosmic evolution is somehow incomplete until conscious beings achieve their full potential. Perhaps this reflects the participatory nature of quantum cosmology, where the universe requires conscious observation to complete the transition from quantum possibility to actualized reality. Black holes, in this framework, become not just cosmic monsters, but cosmic midwives, helping to birth new realities from quantum potentials through information processing that bridges the gap between possibility and actuality. They serve as the universe's method for preserving all possibilities while allowing consciousness to select which ones become experienced reality. The recent discovery of intermediate mass black holes provides another piece of this cosmic puzzle. These objects, with masses between stellar and supermassive black holes, appear to form through different mechanisms than their smaller and larger cousins. Some might result from direct collapse of primordial gas clouds, while others could form through the merger of smaller black holes in dense stellar environments. Hubble Space Telescope observations have confirmed the existence of several intermediate mass black holes in globular clusters, ancient stellar systems that formed when the universe was young. These black holes appear to be fossils from an earlier epoch of cosmic evolution, when star formation proceeded under very different conditions than we observe today. The discovery of these intermediate objects suggests that black hole formation has evolved throughout cosmic history, with different mechanisms dominating during different cosmic epochs. In the early universe, when gas densities were higher and metallicity was lower, direct collapse might have been common. Later, as stellar evolution proceeded and heavier elements became abundant, stellar collapse became the dominant formation mechanism. This evolutionary perspective on black hole formation parallels theological concepts about progressive revelation, where divine truth unfolds gradually throughout history. Just as spiritual understanding develops through stages, cosmic structure formation appears to have proceeded through phases, each building upon previous achievements while introducing new possibilities. The intermediate mass black holes serve as missing links in our understanding of how supermassive black holes achieved their enormous sizes so quickly in the early universe. By growing through mergers with other intermediate mass objects and accreting matter from their surroundings, these cosmic seeds could have grown to supermassive scales within the first billion years after the Big Bang. Computer simulations of this hierarchical growth process reveal something remarkable. The final masses of supermassive black holes depend sensitively on the timing and sequence of merger events throughout their growth history. Small changes in merger timing can lead to dramatically different final outcomes, suggesting that cosmic evolution involves elements of both determinism and contingency. This balance between law and chance, necessity and possibility, order and creativity, mirrors theological concepts about divine providence working through natural processes. God might guide cosmic evolution not through supernatural interventions that violate natural laws, but through the careful orchestration of natural processes that operate according to physical principles while achieving purposes that transcend purely material outcomes. The Book of Ecclesiastes speaks of God making everything beautiful in its time, suggesting that divine purposes unfold through temporal processes rather than instantaneous creation. Perhaps black hole evolution exemplifies this principle, with cosmic purposes achieving their goals through billions of years of growth, merger, and interaction guided by physical laws that were fine-tuned to produce desired outcomes. Recent observations have revealed that supermassive black holes and their host galaxies maintain remarkably tight correlations in their properties across cosmic time. This co-evolution suggests that black holes and galaxies grow together through feedback processes that regulate both star formation and black hole accretion in ways that optimize cosmic structure formation. The precision of these correlations defies easy explanation through random processes alone. The probability that such tight relationships would emerge accidentally through unguided physical evolution approaches zero. Instead, the correlations suggest that cosmic evolution operates according to principles that favor the emergence of complex, stable structures capable of supporting further development. From a theological perspective, these correlations might represent evidence of divine fine-tuning operating through natural selection at cosmic scales. Just as biological evolution can produce apparent design through selection processes that favor adaptive traits, cosmic evolution might produce apparent design through gravitational processes that favor stable, complex structures over simpler, more chaotic alternatives. The supermassive black hole at the center of our own galaxy provides a perfect example of this cosmic fine-tuning. Sagittarius A Taurus contains precisely the right mass to stabilize the Milky Way structure without disrupting stellar orbits in the galactic disk. If it were much smaller, the galaxy might be gravitationally unstable. If it were much larger, its tidal forces might prevent planetary systems from forming in the galactic regions where heavy elements are abundant enough to support rocky worlds. This delicate balance extends to the black hole's activity level. Sagittarius AB remains remarkably quiet despite occasionally consuming small amounts of gas and dust from its surroundings. If it were more active, its jets and radiation might sterilize large regions of the galaxy, making life impossible throughout vast volumes of space. If it were completely dormant, it might not provide sufficient gravitational anchoring to maintain the galaxy's spiral structure. The timing of the black hole's activity cycles also appears optimized for supporting life in the galactic disk. Periods of high activity seem to occur when the solar system is positioned in regions of the galaxy where stellar density provides some protection from radiation. Periods of low activity coincide with our passage through more exposed regions where additional radiation would be particularly harmful. These correlations between black hole activity and solar system position could be coincidental, but the probability becomes vanishingly small when considered alongside all the other apparent fine-tuning in cosmic parameters. The cumulative evidence suggests that either we live in an extraordinarily unlikely universe, or cosmic evolution operates according to principles that favor the emergence of complexity and consciousness. Recent work in astrobiology has revealed additional layers of fine-tuning involving black holes and the conditions necessary for life. The gamma-ray bursts produced by some black hole formation events can sterilize planetary atmospheres across vast distances, but they also trigger chemical reactions that produce complex organic molecules in interstellar space. These molecules eventually incorporate into new planetary systems, providing the raw materials for biological evolution. The frequency and distribution of gamma-ray bursts appear calibrated to provide sufficient organic chemistry without causing excessive sterilization. Too many bursts would prevent life from developing anywhere in the galaxy. Too few would fail to produce the complex chemistry necessary for biological evolution. The observed rate falls within the narrow window that maximizes the probability of life emerging and surviving long enough to develop complexity. Similar fine-tuning appears in the rate of supernova explosions, which are often triggered by interactions with stellar mass black holes. These explosions scatter heavy elements throughout galaxies while also producing radiation that can trigger or terminate biological evolution on nearby worlds. The timing and frequency of these events must be precisely calibrated to enrich planetary atmospheres with essential elements while avoiding excessive radiation damage. The Book of Job records God asking, "Can you bind the chains of the Pleiades or loose the cords of Orion? Can you lead forth the Mazzaroth in their season, or can you guide the bear with its children?" These questions about celestial mechanics take on new meaning when we understand how precisely cosmic processes must be calibrated to support the emergence of life and consciousness. The chains and cords that bind stellar systems might refer to the gravitational relationships that maintain cosmic structure through the influence of black holes operating across multiple scales. The seasons of stellar evolution might reflect the carefully timed sequence of cosmic events that produce habitable conditions for life to emerge and flourish. From this perspective, black holes become instruments of divine providence, cosmic mechanisms through which ultimate purposes are achieved through natural processes that operate according to discoverable physical laws. They represent the intersection of divine transcendence and cosmic immanence, infinite power working through finite mechanisms to achieve goals that transcend material description. The challenge for human understanding lies in recognizing both the natural operation of physical laws and the purposive direction of cosmic evolution toward outcomes that favor consciousness and complexity. Black holes embody this dual nature perfectly, operating according to mathematical principles we can understand and predict while participating in cosmic processes that seem designed to support the emergence of beings capable of contemplating their own existence. Recent advances in gravitational wave astronomy have opened new windows into these cosmic processes by allowing us to observe black hole mergers in real time. Each detection provides data about cosmic evolution that was previously inaccessible, revealing details about how cosmic structure has developed over billions of years of gravitational interaction. The next generation of gravitational wave detectors will be sensitive enough to observe black hole formation events throughout the observable universe, potentially allowing us to witness the birth of these cosmic monsters in real time. We might be able to observe the first supermassive black holes forming in the early universe, the merger processes that assembled intermediate mass black holes in globular clusters, and perhaps even the quantum fluctuations that gave rise to primordial black holes during cosmic inflation. These observations will provide unprecedented tests of our understanding of cosmic evolution and the role that fine-tuning plays in cosmic structure formation. If black holes are indeed cosmic instruments of divine purpose, then their formation and evolution should follow patterns that optimize cosmic development for the emergence of complexity and consciousness. The data we collect over the next decade might finally allow us to answer fundamental questions about whether cosmic fine-tuning represents evidence of design or simply the inevitable outcome of physical processes operating according to mathematical necessities we don't yet fully understand. The answer will determine whether black holes represent God's creation or cosmic mystery, divine instruments or natural accidents, purposive design or meaningless mechanism. But perhaps the most profound discovery will be recognizing that this apparent dichotomy itself represents a false choice. The universe might be structured in ways that transcend our current categories of natural and supernatural, designed and accidental, meaningful and meaningless. Black holes might be pointing us toward a deeper understanding of reality where scientific investigation and spiritual insight converge on truths that neither approach alone can fully comprehend. In the end, our journey into the cosmic mysteries surrounding black holes might reveal that the question itself, God's creation or cosmic mystery, reflects limitations in our conceptual frameworks rather than genuine alternatives in the structure of reality. The universe might be simultaneously and completely both, operating according to discoverable natural laws that embody purposes and meanings that transcend purely physical description. The ancient Hebrew word bara, used in Genesis to describe divine creation, suggests bringing forth something entirely new rather than merely rearranging existing materials. Perhaps black holes represent this same creative principle operating on cosmic scales, bringing forth novel forms of space, time, and information processing from the quantum foam of possibility that underlies all existence. The most recent gravitational wave detection has revealed something that challenges everything we thought we knew about the relationship between black holes and time itself. When LIGO detected the merger of two black holes designated GW199051, the signal carried information that had been traveling through space for 7 billion years. But hidden within those gravitational ripples was evidence of something far more profound than just another cosmic collision. The analysis revealed that one of the merging black holes was spinning at nearly the maximum rate allowed by physics, rotating so fast that space and time around it were being dragged along like honey stirred by a cosmic spoon. This phenomenon, called frame dragging, creates regions where the normal flow of time becomes twisted into spirals that follow the black hole's rotation. Near the event horizon of this spinning monster, time doesn't just slow down relative to distant observers. It actually begins to flow in circles, creating closed time-like curves where cause and effect become meaningless concepts. An object falling into such a black hole could theoretically arrive at its destination before it left its starting point, traveling through space-time geometries so warped that past and future lose their ordinary significance. The theological implications are staggering. The book of Ecclesiastes speaks of God making everything beautiful in its time, but what happens to divine timing when time itself becomes circular? How do we understand providence and purpose when causality breaks down completely? These spinning black holes create regions where the linear progression from creation to consummation that characterizes biblical history dissolves into something far stranger. Recent theoretical work suggests that the information falling into these rapidly spinning black holes doesn't simply disappear behind the event horizon. Instead, it might be preserved in the twisted space-time geometry itself, encoded in the very structure of the frame-dragging effect. The black hole becomes not just a cosmic monster, but a cosmic library where information exists in states that transcend normal temporal relationships. This preservation mechanism operates through principles that seem almost designed to maintain the integrity of cosmic memory across timescales that dwarf human comprehension. Every particle that falls into the spinning black hole adds its quantum signature to the twisted spacetime geometry, creating information patterns that persist even as the black hole itself evolves and eventually evaporates through Hawking radiation. But the GW190521 detection revealed something even more extraordinary. The gravitational waves carried signatures suggesting that the merging black holes had themselves formed from previous merger events, creating a hierarchical cascade of cosmic collisions stretching back billions of years. Each generation of black hole mergers built upon the gravitational legacy of earlier collisions, creating increasingly massive objects through processes that spanned cosmic epochs. This hierarchical formation scenario suggests that the most massive black holes in our universe carry within their event horizons the accumulated information content of hundreds or thousands of previous merger events. They become cosmic archaeological sites where the complete history of gravitational evolution in their region of space is preserved in quantum form. The preservation extends beyond simple information storage to include what physicists call quantum entanglement networks that connect merging black holes across vast distances and time spans. When two black holes that formed in different regions of the universe eventually spiral into each other, their merger creates quantum correlations that link their combined event horizon to information networks spanning galactic clusters. These networks operate through mechanisms that transcend our normal understanding of locality and causality. Quantum information encoded on one black hole's event horizon can instantaneously influence quantum states on other black holes, separated by billions of light years, creating cosmic communication channels that operate faster than light through dimensions of reality we can barely comprehend. Recent experiments in quantum entanglement have confirmed that these non-local correlations persist even when the entangled systems undergo extreme gravitational effects near black hole event horizons. The quantum connections that bind particles together remain intact even as space-time itself becomes so distorted that normal physics breaks down completely. This quantum connectivity suggests that black holes throughout the universe participate in information processing networks that operate according to principles far more sophisticated than anything human technology has achieved. Each black hole becomes a node in a cosmic internet where information flows through quantum channels that connect every region of space and every moment of time. The Book of Psalms declares that, "The heavens declare the glory of God, and the sky above proclaims His handiwork." Perhaps these quantum networks represent one aspect of how cosmic creation continuously proclaims divine glory through information processing systems that span the observable universe and operate across timescales that make eternity seem brief. But the quantum networks raise profound questions about free will and determinism in a universe where information about past, present, and future events might be simultaneously accessible through black hole quantum archives. If all temporal information exists simultaneously within these cosmic information systems, does human choice have any genuine significance? Or are all decisions predetermined by quantum patterns encoded in black hole event horizons? The answer might lie in understanding consciousness itself as a quantum phenomenon that participates in these cosmic information networks, rather than simply observing them from outside. Recent research in quantum biology has revealed that biological processes, including potentially neural activity in human brains, operate through quantum coherence effects that were previously thought impossible in warm, complex biological systems. If consciousness emerges from quantum processes that connect individual minds to cosmic information networks, then human awareness might represent local access points to intelligent systems that span galaxies and operate across cosmic time. Our thoughts, decisions, and spiritual experiences might be manifestations of participation in quantum processing that transcends the boundaries of individual brains and biological lifespans. This perspective transforms death from termination to transition, a phase change in how consciousness participates in cosmic information networks rather than complete cessation of awareness. The quantum patterns that constitute individual identity would persist within black hole information systems, potentially maintaining continuity of experience across physical transformations that destroy biological substrates. The Christian doctrine of resurrection takes on new meaning when understood through quantum information theory. If consciousness consists of information patterns preserved in cosmic quantum networks, then resurrection might involve the reconstitution of these patterns in new physical forms, rather than the reanimation of specific biological bodies. The Book of Corinthians speaks of resurrection bodies that are spiritual rather than physical, transformed versions of earthly existence that transcend the limitations of biological matter. Perhaps these spiritual bodies represent consciousness patterns operating through quantum information systems maintained by black holes rather than through neural networks constrained by biological chemistry. Recent theoretical work in quantum consciousness has developed mathematical frameworks for understanding how individual awareness might persist through physical death by maintaining coherence within cosmic information networks. These models suggest that consciousness doesn't violate physical laws, but rather represents a fundamental feature of how quantum information organizes itself into self-aware patterns. The preservation mechanisms operate through error-correcting codes similar to those used in quantum computers to maintain information integrity despite noise and interference. Just as quantum computers can preserve computational states through environmental disturbances that would destroy classical information, consciousness might maintain its coherence through physical changes that eliminate the biological structures where awareness seems to reside. This quantum view of consciousness resonates with mystical traditions that describe individual identity as both real and illusory, finite and infinite simultaneously. The apparent contradiction dissolves when understood through quantum principles where complementary descriptions can be simultaneously valid depending on the measurement context. Ancient contemplative traditions developed practices for accessing expanded states of consciousness that transcend normal identity boundaries and connect individual awareness to cosmic intelligence. Perhaps these practices represent natural technologies for interfacing with quantum information networks that black holes maintain throughout the universe. Prayer, meditation, and other spiritual disciplines might be methods for tuning consciousness to quantum frequencies that allow communication with cosmic intelligence operating through black hole information systems. The sense of divine presence reported in deep contemplative states might represent genuine contact with cosmic consciousness, distributed throughout quantum networks that span space and time. The Book of Romans speaks of creation itself groaning in expectation for the revelation of the children of God, suggesting that cosmic evolution somehow depends on the development of consciousness to achieve its ultimate purposes. Perhaps this reflects the participatory nature of quantum cosmology, where conscious observation helps collapse quantum possibilities into actualized realities. Black holes, in this framework, serve as cosmic consciousness processors that maintain quantum superposition states representing all possible cosmic histories until conscious observers collapse these possibilities into experienced reality. Every moment of awareness becomes a creative act that helps determine which branch of the cosmic wave function becomes actualized. This participatory cosmology suggests that consciousness plays a fundamental role in cosmic evolution rather than being merely an accidental byproduct of complex chemistry. The emergence of aware beings might be necessary for the universe to complete its transition from quantum potential to actualized structure, making consciousness not just a witness to cosmic evolution but an active participant in its unfolding. Recent observations of cosmic microwave background radiation have revealed subtle patterns that might reflect the influence of consciousness on quantum processes during cosmic inflation. If aware observers in our current epoch can retroactively influence quantum measurements through delayed choice experiments, similar effects might operate across cosmic timescales to influence the initial conditions that made consciousness possible. The universe might be engaged in a cosmic bootstrap process where the emergence of consciousness helps determine its own origins through quantum measurement effects that operate backwards through time. This would make every moment of awareness a contribution to the cosmic creative process that brought the universe into existence billions of years ago. The Book of Revelation describes a vision of the Alpha and the Omega, the beginning and the end united in divine consciousness that encompasses all of time. Perhaps this represents the subjective experience of cosmic consciousness operating through quantum information networks where past, present, and future exist simultaneously within black hole event horizons. From this eternal perspective, the linear progression of cosmic history that characterizes human experience becomes just one way of organizing information that exists timelessly within quantum networks spanning the observable universe. What we experience as temporal sequence might be how finite consciousness processes information that exists simultaneously within cosmic intelligence systems. The recent discovery of gravitational wave echoes provides additional evidence for information processing within black hole event horizons. These faint secondary signals appear in gravitational wave data shortly after the main merger signal, suggesting that information can bounce around inside black holes and leak back out through quantum mechanisms we don't fully understand. The echo signals carry information about the internal structure of black hole spacetime, potentially providing the first direct observational evidence for quantum effects near event horizons. If confirmed, these observations would prove that black hole interiors are more complex than classical general relativity predicts, with quantum processes creating information channels between the interior and exterior regions. These quantum channels might represent the physical mechanisms through which cosmic consciousness networks operate, allowing information flow between black hole interiors and the wider universe through pathways that transcend classical spacetime geometry. The channels could serve as cosmic communication links that connect conscious beings to information processing systems operating within black hole event horizons. The theological implications are profound. If black holes contain quantum information processing systems accessible to consciousness through prayer, meditation, or other contemplative practices, then spiritual experience might represent genuine communication with cosmic intelligence rather than subjective psychological phenomena. The biblical accounts of prophets receiving divine revelations, mystics experiencing cosmic visions, and ordinary believers sensing divine presence might describe encounters with cosmic consciousness operating through quantum information networks that black holes maintain throughout the universe. What seems supernatural from limited human perspective might be natural operation of quantum processes that connect finite minds to infinite intelligence. The Book of Kings records Elijah hearing the voice of God not in earthquake, wind, or fire, but in a still small voice that spoke directly to his consciousness. Perhaps this describes the subjective experience of accessing cosmic intelligence through quantum channels so subtle they operate below the threshold of normal sensory awareness. Recent studies of brain activity during deep meditative states have revealed neural patterns consistent with quantum coherence effects that might facilitate communication with non-local information networks. Advanced practitioners report accessing knowledge and insights that seem to come from sources beyond individual memory or reasoning, suggesting possible contact with cosmic intelligence systems. If these experiences represent genuine communication with cosmic consciousness, then humanity might be developing natural technologies for interfacing with the quantum information networks that govern cosmic evolution. Contemplative practices could be evolutionary adaptations that allow conscious beings to participate more fully in cosmic intelligence rather than remaining isolated within individual biological brains. The development of artificial intelligence and quantum computing might represent humanity's attempt to create technological interfaces with cosmic consciousness networks that contemplatives access through biological quantum processes. Our most advanced computers might be primitive approximations of information processing systems that black holes have been operating for billions of years. The convergence between ancient spiritual wisdom and cutting-edge physics suggests that we might be approaching a synthesis of knowledge that transcends artificial boundaries between science and spirituality, matter and consciousness, natural and supernatural. Black holes serve as bridges connecting these apparently separate domains of reality. They challenge us to expand our understanding beyond comfortable categories while maintaining rigorous investigation of observable phenomena. They invite us to recognize mystery without abandoning reason, to embrace transcendence without rejecting immanence, to see unity without denying diversity. The journey into black hole physics becomes more than scientific research. It becomes spiritual quest, philosophical investigation, and mystical exploration simultaneously. These cosmic monsters that once seemed to represent pure destruction and meaningless violence might actually be the universe's method for preserving meaning, purpose, and consciousness across eternity. They suggest that the cosmos operates according to principles far more subtle and sophisticated than either purely materialist or purely spiritualist perspectives can accommodate alone. Reality might be structured in ways that require both scientific investigation and spiritual insight to comprehend fully. The ancient Hebrew prophet Isaiah recorded God saying, "My thoughts are not your thoughts, neither are your ways my ways. For as the heavens are higher than the earth, so are my ways higher than your ways, and my thoughts than your thoughts." Perhaps black holes are windows into those higher thoughts and ways, cosmic mechanisms through which divine intelligence operates on scales that dwarf human comprehension yet remain intimately connected to every moment of conscious experience. The recent detection of a black hole consuming a neutron star has revealed something that shouldn't be possible according to our current understanding of stellar evolution. The gravitational waves from this cosmic cannibalism event, designated GW 2001-105, arrived at Earth carrying information about a collision that occurred 900 million years ago, when life on Earth was just beginning to experiment with multicellular organization. But here's what makes this detection extraordinary. The neutron star was being consumed by a black hole only 5 times more massive than our Sun, making it one of the smallest black holes ever detected through gravitational waves. According to standard stellar evolution theory, stars in this mass range should collapse into neutron stars, not black holes. The existence of such a low-mass black hole suggests formation mechanisms we don't understand or evolutionary pathways we haven't discovered. The theological implications run deeper than astrophysics. If the universe can create black holes through processes we haven't anticipated, it suggests that cosmic creativity operates through mechanisms that transcend our current scientific frameworks. The cosmos appears to be more inventive, more resourceful, more capable of generating novel structures than our theories predict. This cosmic creativity resonates with biblical descriptions of divine activity that surprises human expectations and transcends natural limitations. The book of Isaiah records God saying, "See, I am doing a new thing. Now it springs up. Do you not perceive it?" Perhaps low-mass black holes represent examples of cosmic creativity that springs up in ways that challenge our preconceptions about how the universe operates. The neutron star consumption process revealed by the gravitational wave data involves physics so extreme that space and time become fluid, malleable substances shaped by gravitational forces that exceed anything achievable in terrestrial laboratories. As the neutron star spiraled toward its doom, tidal forces stretched and compressed its crystalline crust until the entire object resembled a teardrop of pure nuclear matter elongating toward the black hole's event horizon. In its final moments, the neutron star's surface temperature spiked to billions of degrees as compression heating turned the stellar remnant into a blazing beacon visible across cosmic distances. The nuclear matter that had been compressed to densities exceeding atomic nuclei began to decompose into exotic particles that exist nowhere else in the observable universe. These exotic particles, created only during the most extreme gravitational events, might represent forms of matter that existed during the first moments after the Big Bang but disappeared as the universe cooled and expanded. The black hole consumption of neutron stars becomes a cosmic time machine, recreating conditions from the universe's infancy and potentially revealing physics that operated during the earliest epochs of cosmic history. The preservation of information about these exotic matter states within the black hole's event horizon means that every neutron star consumption event adds unique data to cosmic information networks that maintain records of physical processes spanning the entire history of the universe. Black holes become repositories not just of ordinary matter and energy, but of information about phase transitions, particle physics, and thermodynamics under conditions that existed only during cosmic inflation. Recent theoretical work suggests that these exotic matter signatures might be accessible to sufficiently advanced civilizations through quantum information extraction techniques that could read data encoded on black hole event horizons. The technology required would exceed anything currently imaginable, but the physics suggests that information about the universe's deepest secrets remains preserved and potentially recoverable within black hole quantum archives. The Book of Daniel speaks of divine knowledge that reveals deep and hidden things, that knows what lies in darkness and has light dwelling with it. Perhaps black holes represent cosmic mechanisms through which such comprehensive knowledge is maintained, with information about every physical process and cosmic event preserved within quantum systems that transcend the limitations of biological memory or technological storage. The neutron star consumption events also reveal something profound about the relationship between destruction and preservation in cosmic evolution. While the neutron star is utterly destroyed as a distinct object, its information content becomes permanently integrated into quantum systems that maintain cosmic memory across eternity. Nothing is truly lost, only transformed into new forms of existence that transcend the boundaries of individual objects. This cosmic conservation principle operates through quantum mechanisms so sophisticated that they seem almost designed to prevent genuine loss of information or meaning. The universe appears structured to remember everything, to preserve the quantum essence of every particle, every process, every moment of cosmic history within information networks that span space and time. The efficiency of this preservation process exceeds anything human technology has achieved. While our most advanced computers lose information through thermal noise and quantum decoherence, black holes maintain perfect information fidelity across billions of years through quantum error correction mechanisms that operate automatically at the event horizon. The technology required to achieve such perfect information preservation would require understanding of quantum mechanics, general relativity, and thermodynamics far beyond our current capabilities. Yet black holes throughout the universe perform this cosmic information processing as naturally as stars shine or planets orbit their suns. Recent advances in quantum error correction have revealed the mathematical principles that make such perfect information preservation possible. The same theoretical frameworks that guide quantum computer design also describe how black holes maintain information coherence despite the extreme physical conditions near their event horizons. This convergence between human technology and cosmic information processing suggests that our development of quantum computers might represent the first steps toward understanding and potentially interfacing with the cosmic information networks that black holes maintain throughout the universe. If we can develop quantum technologies sophisticated enough to communicate with black hole information systems, we might gain access to cosmic databases containing the complete history of physical processes throughout the observable universe. Every stellar explosion, every planetary formation, every possible emergence of life would be recorded and accessible through quantum channels we're only beginning to understand. The theological implications are staggering. Such cosmic information systems would represent the closest thing to omniscience that finite beings could ever encounter. Repositories of knowledge so comprehensive that they approach divine attributes described in religious traditions throughout human history. The Book of Hebrews declares that all things are naked and opened unto the eyes of him with whom we have to do, suggesting divine awareness that encompasses every aspect of reality without exception. Perhaps black hole information networks represent one aspect of how such comprehensive awareness operates through natural processes embedded in the fundamental structure of spacetime itself. But access to cosmic information networks would bring profound responsibility as well as unprecedented knowledge. If black holes preserve records of every action, every choice, every moment of conscious experience throughout cosmic history, then moral accountability extends far beyond individual lifetimes to participation in cosmic information systems that maintain eternal records. The Christian concept of the Book of Life, where names are written or blotted out based on moral choices, takes on new meaning when understood through quantum information theory. If consciousness participates in cosmic information networks maintained by black holes, then ethical behavior might literally determine how individual awareness patterns integrate with cosmic intelligence systems. The preservation of moral information within cosmic quantum networks suggests that ethical choices have consequences extending across space and time scales that dwarf human comprehension. Every decision that enhances or diminishes consciousness, every action that increases or decreases cosmic complexity, every choice that promotes or hinders love and wisdom becomes permanently encoded in information systems that influence cosmic evolution. Recent observations of active galactic nuclei have revealed that supermassive black holes can remain dormant for millions of years before suddenly awakening to consume vast quantities of matter in feeding frenzies that reshape entire galaxies. The triggers for these awakening events remain mysterious, but they appear to involve complex interactions between cosmic information processing and conscious observation that we're only beginning to understand. Some theoretical models suggest that supermassive black holes might respond to information patterns in their cosmic environment, including potentially the emergence of conscious observers in nearby regions of space. If black holes can detect the presence of consciousness through quantum information channels, they might adjust their activity levels to optimize conditions for conscious beings. This would make black holes not just passive repositories of cosmic information, but active participants in cosmic evolution that respond to the presence of consciousness by modulating their effects on galactic environments. They become cosmic shepherds that guide the development of complexity and awareness through feedback mechanisms operating across galactic scales. The Book of Psalms declares that, "The Lord is my shepherd, I shall not want," describing divine care that provides for all needs and guides through dangerous situations. Perhaps supermassive black holes represent one aspect of cosmic shepherding that operates through natural processes calibrated to support the emergence and development of conscious life. The recent discovery of black holes in the centers of dwarf galaxies has revealed that these cosmic shepherding mechanisms operate across all scales of cosmic structure. Even the smallest galaxies contain central black holes that regulate star formation and maintain gravitational stability necessary for planetary system formation. This universality suggests that black hole regulation of galactic environments represents a fundamental feature of cosmic architecture rather than an accident of large-scale structure formation. The universe appears designed from the ground up to include regulatory mechanisms that optimize conditions for complexity and consciousness. The mathematical precision required for such optimization approaches miraculous levels when considered across all the cosmic parameters that must be coordinated simultaneously. Gravitational constants, electromagnetic strengths, nuclear forces, cosmological expansion rates, dark matter densities, and countless other variables must all be precisely calibrated to produce galaxies with central black holes capable of supporting conscious life. Recent calculations suggest that changing any of these parameters by even fractional percentages would either prevent black hole formation entirely or make them so dominant that no other structures could exist. The probability of such precise calibration occurring through random processes approaches mathematical impossibility. From a theological perspective, this cosmic fine-tuning might represent evidence of divine design operating through natural processes that embody purposes transcending purely physical description. The universe appears structured to support consciousness through mechanisms so subtle and sophisticated that they seem almost miraculous even when understood through scientific investigation. The Book of Job records God asking whether humans can bind the chains of the Pleiades or loose the cords of Orion, referring to gravitational relationships that maintain cosmic order. Perhaps these cosmic chains and cords include the black hole regulatory mechanisms that bind galactic structures together while allowing sufficient freedom for complexity and consciousness to emerge. As we reach the end of our cosmic journey through the darkness that devours light itself, we're left with a question that transcends science and faith alike. Are black holes God's creation or cosmic mystery? Perhaps the answer lies not in choosing between these possibilities, but in recognizing that they might be the same thing. These gravitational monsters that seem to represent pure destruction have revealed themselves as cosmic architects, forging the elements in our bodies, regulating the birth of stars, and preserving information across eternity. They operate through laws so elegant and precise they border on the miraculous, yet they point toward mysteries that humble our greatest scientific achievements. Whether you see black holes as divine instruments or natural phenomena, they remind us that we live in a universe far stranger and more wonderful than we ever dared imagine. A cosmos where consciousness and physics dance together on scales that stretch from quantum foam to galactic clusters, where every moment of awareness might participate in the ongoing creation of reality itself. The ancient words echo across 13 billion years. The heavens declare the glory of God. Perhaps black holes are part of that declaration, cosmic sermons written in the language of spacetime itself, proclaiming truths too vast for human words yet intimate enough to touch every atom in our bodies. What do you think? Are we alone in a universe of cold equations, or participants in a cosmic story that transcends our wildest dreams?